So my talk is about extracting and tracking of dialogue object from these noise-corrupted mixtures. And we heard a lot in this morning's talk about this audio object in spatial audio, and there can be many different formats for audio object. For example, they can be environmental, as mentioned previously by Philip. For example, the reverb object, and also they can be about sound itself, contain some audio signals, and also some metadata describing the acoustic properties like the distance, the position, loudness, diffuseness. And one of the most commonly sound thing is dialogue things, and therefore we might need to use lots of dialogue object. And in this case, the dialogue object will contain a dry, clean speech signals as well as some metadata. And the most important metadata we often use is the 3D positions of the speakers in the sound thing. We know that in some ideal recording environment, we can simply directly record a clean speech signals and without much interference. And also the sound designers or the producers, they can just manually set the positions of the speech in a sound thing. But in some other real world recordings, things are a little bit different. And there might be multiple speakers speaking at the same time, and also there might be some very heavy background noise. So we get some corrupted speech signals that we need to apply some speech enhancement algorithm to extract dialogue out of this noise corrupted speech signal. And also another thing is that if we want to reconstruct the original sound things, we need to figure out exactly at each time moment the positions of the target speaker that we are interested in. And so we have two tasks. And the first task, we need to apply speech enhancement or for the extraction or suppression of the dialogue signals. And this is often related to the cocktail party problem. And we can see this simplified diagram showing this cocktail party problem. There are two speakers speaking at the same time, and also there's some background music noise. And for a person with these normal hearing abilities, he can just simply focus and extract the speech he is interested in and ignore the other interfering speakers and the noise. And so our research question is that can we use machines to mimic this human listening process? And the answer is yes. And over the last 30, 40 years, there are quite many algorithms developed to solve this cocktail party problem. And the most popular ones is blind suppression. And there are many traditional methods, classic blind suppression algorithm like independent component analysis, but they have the problem that their performance is often degraded in some adverse environment. And the recent advances in deep neural network help us to overcome these limitations. And this diagram shows how we can use deep neural network to solve this blind suppression problem. We extract some features and feed into deep neural network and hopefully get these enhanced speech signals. And we have three main contributions in this part of work. And firstly, we have proposed a perceptually motivated loss which controls the training of deep neural network. And secondly, we propose a position robust spatial features. This will greatly relax the training process of deep neural network. And thirdly, we have combined speech synthesis with this blind suppression. So we can fake or synthesize speech signal with high fidelity. And the second task is to extract some speakers. And we can use the audio tracking, but it suffers from accuracy problem. And we can use visual tracking. It's accurate enough, but it suffers from occlusion problem. So we combine strengths of both modalities and propose a joint audio-visual tracking method. And the audio tracking and visual tracking, they are firstly processed in parallel, and then they are integrated with this fusing network. Right. And this demo shows the track. Get some demo to show the tracking with the video tracking field to detect the person, and our proposed method can consistently track the targeted speaker. Right, so Thank you very much.